So today we are going to be talking about ellipses. It is another conic section. It is a circle, but it is a stretched circle. So this picture just shows how an ellipse is formed. So if I were to take a string and thumbtack the string down, okay, and then use my pencil to trace wherever I could, as far as the string could reach, it would reach out here and create this ellipse. Okay, so an oval shape. And the points where the string is attached are called my foci. Okay. All right, so let's talk about the parts of an ellipse. So we have a major axis. The major axis is always the longest. The length of the entire major axis is 2a. So from the center to a vertex is a. Okay, so this point on my longest axis is called my vertex. We also have our foci. So if you look back at this picture up here, our foci were on our longer axis. So our foci are these 2 points inside of our vertex, between our vertex and our center. And that distance we're going to call distance C. Okay, so this is a foci, our focal point. And then the last thing that we have is our minor axis. So our minor axis is our shortest segment going through the center. And that distance is B, from the center to the co-vertex. So those are the points that we're going to be working with on these. So you have 2 different types of ellipses. You have ellipses that are horizontal, and you have ellipses that are vertical. We're not going to talk about any that are oblique or, at an angle right now. We're just talking about horizontal and vertical. Okay, so the main points you need to know: the major axis is at the vertex or vertices. The minor axis ends at co-vertices. Your foci is inside of your vertices. And then you need to know this equation. So there's a couple of equations for ellipses you have to know. A squared minus b squared equals c squared. Very similar to the Pythagorean theorem. However, that is not a plus, okay? Because we are not looking for, so if it was a squared plus b squared, right, we would be looking for this distance right here as c. But that is not the case. We're looking for this distance squared minus this distance squared to give us this c distance right there. Okay. So it's a little bit different than what you're used to seeing. It is not the Pythagorean theorem. Very similar. So our equations are the other things that you're going to have to memorize. Okay. So our equations are very similar to a circle, except you have a couple of different changes. So the center part stays the same. There's still a plus between them. But you'll notice you have this a squared and this b squared underneath, or a b squared and an a squared underneath. Okay, so this right here, if the a squared is under your x, then it is a horizontal ellipse. If the a squared is under your y, then it's a vertical ellipse. So that tells us which our major axis is. So in this case, our major axis is our horizontal, going left to right. And here our major axis is our vertical. Okay, and then these are never set equal to a radius because there is no radius for an ellipse. Okay, because this changes, right? Because this is length B and this is length A. So it's set equal to 1 instead. So let's go ahead and take a look at some problems and find the answers to these and graph these. So it says graph the ellipse, state the center, vertices, co-vertices, and foci. So the very first thing I always like to do is find my bigger number. Okay, my bigger number is going to be my a squared. Okay, so that means that this ellipse is going to open horizontally. So my A then is 8, and really it's plus or minus 8, right? And my B is 5, or plus or minus 5. Okay. My center, well, it's just an x squared and a y squared. So I haven't moved at all. So let's go ahead and plot that. And if you're struggling to find the points for the vertices and co-vertices and foci, let's plot it out first. Okay, so my A value is 8, and I know it's going horizontally. So that means I have to go 8 to the left and 8 to the right. So my points then are going to be -8, 0, and 8, 0. So in other words, my x coordinate changed by 8. For my co-vertices, that value is 5. So my length from here to here has to be 5. And from there to there has to be 5. Okay, and we know that if this is my major axis, then my minor axis with my co-vertices is vertical. And now we have to find the foci. So the foci is just a squared minus b squared equals c squared. And so my a squared is 64 minus my b squared equals my c squared. Okay, 64 minus 25 is 39. So the square root of 39 is about 6.2. Okay. So it's between 36 and 49. So I know it's around 6 point something. Okay, and use your calculator. Okay, square root of 39, enter it in your calculator. You're going to get 6.24, I think. So now our foci, we know, are on the same axis as our vertices. So that means it's going to be -6.20. And if you don't know this, then start here, say, okay, my horizontal axis is my major axis. So I need to go 6.2 in either direction from my center. And then it would be 6.20. Okay? So I'm looking for the coordinates. Okay? I'm looking for you to draw the shape. And once again, it does not have to be a perfect oval, but we do want it kind of rounded. Okay. Use pencil, it works the best. All right, so let's go ahead and let's look at the next problem. So the first thing I'm going to do is find my A. So my A term is my biggest term. So we know that this thing is going to open up and down. So my vertices are going to be up and down. My co-vertices are going to be left to right. Okay, so my co-vertices will be going left to right, and my foci will be up and down. So my A value is 6, and my B value is 4, because remember this is B squared and A squared. My center is at 3, 1. I'm going to go ahead and graph that. Okay, from there, I can find out my vertices. So my vertices I know are changing in the vertical direction, which means my horizontal piece is going to stay the same. And I'm just going to add 6 to my vertical, so to 1. Okay, so 1 plus 6 is 7, and 1 minus 6 is -5. So I have 3, -5, and 3, 7. So those are going to be my vertices. My co-vertices are changing on the horizontal axis. So my vertical point coordinate or part from my center is going to stay the same. And I'm just going to go 4 in each direction from 3. So 3 minus 4 is -1, and 3 plus 4 is 7. And now I need to do my foci. So I have a squared minus b squared equals c squared. So 20 equals c squared. So the square root of 20 is approximately, let's see, what is it? 2 point, no, not 2, 4.5. Okay, so it's about 4.5. Okay, and I know that it's going vertical, so my x component is staying the same, and my vertical is changing. So 1 plus 4.5 is 5.5, And 1 minus 4.5 is negative 3.5. And then I can graph those. And then we're going to go ahead and make our ellipse. And we're done. And notice I missed my point a little bit. I'm okay, once again, with these not being perfect. I know some of you want to make them perfect, but they don't have to be exact. They're close to. And let's do another one. So in this one, I'm going to once again find what my major axis is. My 25 is bigger, so my major axis is going horizontal. So my vertices and my foci will be horizontal, and my co-vertices will be vertical. My center is at +2, -4. My A value is the square root of my biggest number, so 5. So my A value should always be bigger than my B value. Always, always. And my B value is going to be 3. All right, so I'm going to go ahead and graph this. So 2, -4. So I'm going to change my X component for my vertices. Okay, so my Y component is going to stay the same. And I'm going to go 2 take away 5, which is -3, and 2 plus 5, which is 7. So -3 and +7. My co-vertices, I'm changing my Y value, and I'm changing it by 3. So -4 minus 3 is -7, and -4 plus 3 is -1. Okay, so -7 and -1. And then my foci, so I'm going to take my 25 minus 9 equals c squared. 25 minus 9 is 16. 16 equals c squared. Take the square root of both sides. So I'm going to get 4 equals c. And that is going left and right. So that means that my Y value is going to stay the same. 2 take away 4 is -2, and 2 add 4 is 6. So, and remember, your foci should always be inside your vertices. So that's just one way to check. Is it working out or not? Okay, because if you get something out here, you've done something wrong. But you've got to remember these formulas. We have some more formulas to go in the next sections. And you have to remember these. All right, so let's go on ahead and take a look at the next couple of problems on here. Okay, and then this will finish it for 5.2. Okay, so it says write the equation for each ellipse in standard form if the center is 0, 0. So all of these are going to have our x squared plus y squared equals 1, and that's not going to change. Okay, all that's going to change are our a and b values. Okay, if our vertex is 6, 0 and our co-vertex is 0, 4, our a value is 6. Our B value is 4, which means A is 36 and B is 16. And you notice my vertex was in my X position. So that means I had to write that A squared under my X term. And that's it. That's the equation. Let's go ahead and take a look at the next one. So the next one has a vertex of -10, 0. And a foci or focus at 8, 0. Okay, so if my vertex is in the X position, that means this thing is opening horizontally. So my A value is 10. Okay, so it's not -10 because we're looking for a distance. It wouldn't matter if it was -10, it would still be squared and that would be still a positive number, but it's a distance. Okay. Our B we don't know, and our C is 64. Okay. So we can go on ahead and start this because we know that it's centered at 0, 0. So we know what that's going to look like. Always an x squared first and then a y squared. Okay, the a and b are what changes. So now I'm going to say a squared minus b squared equals c squared, which is 64. I wrote my c here as 64 instead of 8. So now I'm going to subtract 100 from both sides. I'm solving for b, or b squared is really what I have to know. So negative b squared equals negative 36. Divide both sides by -1 and you get b squared equals 36. Now, yes, we could take the square root of both sides and find out that b is plus or minus 6. But in our equation, we need b squared anyways. So we said this thing is horizontal. So that 100 is going to go here. And that 36 is going to go under the vertical component. Our last problem here, it says the co-vertex is 0, 5 and the focus is -12. So if the co-vertex is 0, 5, that means our b value is 5. Our focus is our c value, which is 12. Okay, I was going to write focus and then I need to write c. All right. So one thing that we need to know, if our co-vertex is in the vertical, right? So our co-vertex is going up or down. So that means that this thing is horizontal and it should be x squared over our a squared plus y squared over our b squared equals 1. Okay. So keep in mind, remember, co-vertex is the minor axis. The minor axis is vertical in this case, which means the major axis is horizontal, which means our a, our bigger number, has to go with our x value. Okay, so let's go on ahead and solve for that a squared. So a squared minus 25 equals 144. So we get a squared equals 169. We don't even need to take the square root of it. We can just plop it right in there. Square root of it is 13. That's fine. Okay, but we really don't care. We just need that a squared value at this point, okay, for this problem. And we have a couple of terms to define. So the eccentricity of an ellipse is defined as the ratio of C to A, where C is the foci. Okay, so it's actually a ratio. So in this case, it would be 8 to 10 would be the eccentricity, or 0.8. The equation of a degenerate ellipse, okay, is the same as, let's go ahead and write it as x minus h squared plus y minus k squared. It's the same exact form, but remember, it equals 0 because our radius is 0, and you'll see later when we start solving these that in order to get 1 here, we have to solve, okay? So this has to be 0. Okay, it still relates to our radius of a circle, but we've done something to it, which is where this a squared and b squared comes in. Because remember, if you think of a vertical stretch or compression, or a horizontal stretch or compression, those are where we multiply on the outside of the parentheses, and that's really what we're doing. We're multiplying by 1 over a squared, or we're multiplying this by 1 over b squared. Okay. And its graph is a point, and just like a circle, it's actually the center point. Okay. So if you were gone today, make sure that you do the 5.2 assignment on APEX if you weren't here. Otherwise, I will see you next time. Have a great day.